Yes. Students, in this video I am discussing the detailed solutions of test 11 chapter on waves. Okay. First question. A transverse wave is represented by the equation y equal to a sine omega t minus of kx. For what value of the wavelength lambda is asking? The wave velocity is equal to the maximum particle velocity. Wave velocity is represented by equal to lambda divided by t, wave velocity. And particle velocity is represented by the equation omega divided by k. Okay. He is asking the question, for what wavelength this wave velocity is equal to the what particle velocity is asking. Okay. For that, lambda divided by t equal to omega divided by what? K here. Okay. Now, here the maximum particle velocity equal to 1 minute. Okay. Now, Now, first, maximum wave velocity equal to what? Lambda by what? T. Okay. This is equal to this is omega into lambda divided by what? 2 pi. Okay. Because omega equal to what? What is the value? 2 pi by what? T. That is. Therefore, T equal to 2 pi divided by what? Omega. Next, maximum particle velocity is represented by what? It is A into what? Omega. That is A into omega. Now I will equate these two equations. I will equate it 1 and 2. I will equate so that omega lambda divided by 2 pi equal to what? A omega. Now which factor get cancels? This omega is what? Get cancels. Now therefore lambda equal to what? 2 pi into what? A. This is the equation. That means this is the right answer. Next. A transverse wave propagating along x-axis is represented by the equation y equal to 8 into sine of this equation. This equation is similar to which equation is y equal to 8.0 into sine of 0.5 pi x minus 4 pi into t minus of what? Pi by 4. Okay, fine. This equation is similar to which equation? Y equal to a into sine of kx minus of what? Kx minus of omega t plus of what? Pi. That is. Here wave is propagating along x-axis, no? That's why this is the equation. Kx minus omega t. Okay. Now wave is propagating along x-axis. Okay. Now compare it this equation now. By comparing both equations, what you will get? K equal to 0.5 into what? Pi. Okay. Omega equal to what? What is the value? Omega equal to 4 into pi. Now, what to be calculated? Speed you have to calculate. Speed equal to V equal to omega by what? K. Substitute the value of this one, that is equal to 4 pi divided by what? 0.5 into pi. Pi it cancels, equal to 40 divided by 5 equal to 8 meter per second. 8 meter per second. So that this is the right choice. Next, sound waves of wavelength lambda is traveling in a medium with a speed of v meter per second, enters into another medium where the speed is what? 2v. the wavelength of the sound waves in the second medium. Students, remember, whenever the waves travels from one medium to another medium, here always velocity is v1, here it is lambda 1. Here the velocity is v2, here the wavelength is what? Lambda 2. But the frequency always remains same, students. In the medium 1 as well as in the medium 2, the frequency always remains same here. That means V equal to F into lambda, we know this. Therefore, F equal to what? V by what? Lambda. That means V1 by lambda 1 equal to V2 divided by what? Lambda 2. Use it. I want to calculate wavelength of the wave. The second medium I want to calculate. Lambda 2 equal to V2 by what? V1 into what? Lambda 1, that is. In the second medium, this is velocity is how much it is? 2v, that is 2v. In the first medium, it is what? V into what? Lambda 1. This get cancels. Therefore, lambda 2 equal to 2 times of what? Lambda 1 here. Or else lambda equal to, this is lambda dash equal to 2 lambda. It is increases by 2 times. So that this is the right. Remember, even in the electromagnetic waves also, whenever the light or sound waves travels from one medium to another medium, always the frequency remains constant. Only the wavelength will be changes and also velocity changes. Next, fourth one. Velocity of sound in a gaseous medium is 330 meter per second. If the pressure is increased by 4 times, okay, pressure increases without change in temperature. Remember, students, velocity of the sound is is independent of pressure here. Velocity of sound is independent of temperature. Independent of temperature. Independent of pressure, that is independent of pressure. So that velocity remains same only, that is 330 meter per second. And but velocity is directly proportional to what? Absolute temperature. Velocity is inversely proportional to what? That is inversely proportional to square root of what? Density. Okay. Next, fifth one. The velocity of sound in air at NTP is 330 meter per second. What will be its velocity when temperature is doubled here? Relation is V is directly proportional to the square root of absolute temperature. That means it should be more than 330 only. More than 330 means this is not at all possible. So that and divided by this also not possible. And this is also not possible, so that this must be what? This one, that is. Because we know that V2 by V1 equal to square root of T2 divided by square root of what? T1 here. Here temperature is doubled, he said that. So that it is 2T divided by what? This is what? T. T get cancels, so that it becomes what? Square root of 2. Therefore, V2 equal to 330 into what? Square root of 2. This is the right answer. Because V1 has given. V1 has given. So that this is the right answer. Next. A wave of frequency 500 hertz travels between X and Y. That distance of 600 meter in 2 seconds. How many wavelengths are there in distance xy? Okay. This point I will call it the x, and this point I will call it as a what? Y, that is. Okay. 600 meter, it is travels 600 meter. In a time t equal to how much it is? 2 seconds. Okay, fine. He is asking how many wavelengths? How many wavelengths? This is one wavelength. Okay. This is one wavelength. This is again, it is second wavelength. Again, this is what? Third wavelength. Like this, how many wavelengths are there? He is asking here. That is. Okay, Now, here velocity equal to distance divided by time equal to 600 divided by 2 equal to 300 meter per second. Okay then. Now, V equal to F into what? Lambda, that is. Okay. Here has given the 500 frequency has given here. Therefore, lambda equal to V by what? F uncalculated. What is the velocity? 300 divided by what? It is 500. Okay, 300. But so that these two it cancels, equal to 3 by 5. That is one wavelength equal to 3 by 5 meter. One wavelength equal to 3 by 5 meter. So that it is total distance traveled. It is how much it is? Total distance traveled divided by what? This wavelength it gives. That is n into lambda equal to distance x. This is the formula. N is number of waves. Lambda is what? Wavelength here. No. Okay. Now you calculate, that is number of waves equal to x divided by what? Lambda here. What is x? Total distance traveled is how much? 600. Wavelength is how much? 3 by what? 5 equal to 3. It is 200 into what? 5 equal to 1000 oscillations. It has made during its journey, that is from 600 meter journey, it is totally, it made how many oscillations here? 1000 oscillations it has made here. So then this is the right answer. Okay. Remember that. Even a similar kind of problems I solved in the regular class also, that is here like this. This is one oscillations. This is second oscillation, like that. This is what? Third, two, and then here up to this it is how much? One oscillation. Up to this, second oscillation. Up to this it is what? Lambda by what? 2. So that total it becomes a 2 end of oscillation. It is similar way, that is. Similar way it is. Okay. Next. 7th one. The displacement of a particle in medium can be represented as, okay, this is the equation, okay, where t is in seconds and x and y are in what? Meters. The speed of the wave is, okay, y equal to 10 to the power minus 6 into sine of 100 into t plus 20x plus of what? Pi by 4. Okay. Now, this equation is similar to which equation? Here, a into what? Sine of what? Omega t plus of what? Kx plus of what? Pi by 4. Tell me students, in what direction wave is traveling? Negative x direction. The wave is traveling in the negative x direction. So that it is a plus sign is there. Negative x direction. Wave is traveling like this. Okay. Of course. Here compare it. This equation, omega equal to what? 100. K equal to what? 20. What to be calculated here? Speed of the wave we have to calculate. V equal to omega by what? K equal to 100 divided by 20 equal to 5 meter per second. So that this is the right answer. Next, the equation y equal to a into cos square 2 pi nt minus 2 pi x by lambda represents a wave. Then these are the possibilities: amplitude equal to a by 2, frequency equal to 2n, wavelength equal to lambda. Second choice, amplitude equal to a by 2, and all that is given. This given equation you have to convert into what? Cos square term is there. No, we need to convert in terms of what? Simple harmonic equation, either sine wave or cos wave, we have to convert it. We know the formula: cos square theta equal to always 1 minus cos of 2 theta divided by what? 2. This is the formula. This is all together, it is theta, it is. This is the theta, it is. Okay. Now, y equal to a as it is I am writing. Okay. Cos square theta, no? I am writing 1 minus cos of 2 theta. 2 theta means 2 into this. 2 into 2 pi n into what? T. Minus, I am multiplying this. 2 into 2 pi x divided by what? Lambda it is. Okay. Divided by, whole divided by what it is? 2. I think I will. You understood this? 2 theta, I am multiplying this to here. This and this. This is, other factors is theta only, that is. Okay. Now, again, y equal to, it is a by 2. Okay. Minus a by 2 into cos of this term. 2 into 2 pi n into t minus 2 into 2 pi by lambda into what? X. Now, this equation, it is limit. This is a constant term, that is. This is what? SHM equation here. SHM equation here, that is. Now, this equation is looks like what? Y equal to a by 2 into cos of this. 2 into 2 pi n into t minus 2 into 2 pi by lambda into what? X. This equation is similar to what? Omega t minus of what? Kx. Omega t minus of what? Kx. Is it right? Y equal to a into cos of omega t minus of what? Kx. Okay. Here, compare it. This equation, you compare it. Now, you compare it here. This is this one. That means amplitude equal to what? A by 2 here. Amplitude equal to a by 2. Amplitude equal to a by 2. So that definitely this is not, this is not. Okay. Next. Now the choice is between A or B here. Omega equal to 2 into 2 pi into what? N here, that is. Okay. Now, here omega equal to what? 2 pi f, we know that. 2 pi f equal to 2 into 2 pi into what? N. Which factor get cancels? This 2 pi is what? Get cancelled. Therefore, f equal to what? 2n, that is. F equal to 2n. F equal to 2n. Okay. Here also f equal to a by 2. This is also 2n. This is also 2n. Still I can't filter it. Again, I have to check the what? Wavelength also, that I have to check it. For this wavelength, now that is a wavelength. Okay. K equal to 2. K equal to what? 2 pi by what? Lambda, that is. I will call equal to 2 into 2 pi divided by what? Lambda. I will call it as a lambda dash. I will call it as temporarily. So that this 2 pi is what? Get cancels. Therefore, reverse it. 1 by lambda dash equal to 2 by lambda, no? It is 1 by lambda dash equal to 2 by what? Lambda. Therefore, lambda dash equal to lambda by 2. So that this is the what? Right answer. Yes. Students, I solved this problem in the regular class also. I solved this. You need to convert trigonometric function I used. Next. A wave traveling in the positive x direction. A wave traveling in the positive x direction, having the displacement along y direction as 1 meter. You see, displacement in y direction is 1 meter, means it is the amplitude has given, that is. Okay. Next, wavelength is what? 2 pi. Amplitude equal to what? 1 meter. And then wavelength equal to what? 2 pi has given. And then frequency equal to what? 1 divided by pi. By using all these things, you need to write the what? Equation, standard equation you need to what? Write it. Okay. Standard equation we know that y equal to what is this? A into sine of okay kx minus of what? Omega t, that is. A wave is traveling in the positive x direction. You see, it is traveling in the positive x direction. Kx minus omega t, that is. Okay. Now, y equal to a is nothing but what? 1 into sine of k. K is nothing but what? K equal to 2 pi by lambda, that is equal to 2 pi divided by lambda is nothing but what? 2 pi. This 2 pi, this 2 pi is what? Get cancels. So that this k is nothing but what it is? 1 only. So that 1 into what? X minus. Okay. That omega you have to calculate. Omega equal to what? 2 pi into what? F here. But what is the value of f? 1 by 2 pi equal to 2 pi into 1 divided by pi. This get cancels. How much you are getting? 2. So that this will be 2 into what? T here. Or else y equal to sine of what? X minus of what? 2t. This is the standard equation, that is. Which one is right? Then x minus 2t. This is the right answer. Okay. Next. If two waves of equal amplitudes A produce a resultant wave of amplitude is what? A. Okay. Here in this problem he has given A1 equal to A, first wave, second wave A2 is also what? A, and the resultant amplitude is also what? A, that is. Okay. What is the phase difference? I solved the regular class also. R square equal to, that is a P square plus Q square plus 2PQ into what? Cos theta. Or else you can use it R square equal to A1 square plus A2 square plus 2 into A1 into A2 into what? Cos theta. You can use it. Probably in the regular class I have taken the square root, I have taken R equal to. No problem. Here this is A square. This also what? A square. This also what? A square. Plus 2A square into what? Cos theta. Simplified. This A square is what? Get cancels. That is now simplify. So that this is A square, A. So 1 equal to A square is the common factor. 1 plus 2 into what? Cos theta. That is what? 2 cos theta. Okay, this A square is also what? 1 minute. I made mistakes here. That is okay. 1 minute. A square equal to A square plus of A square plus 2A square into what? Cos theta. Okay. This is the resultant amplitude. A square equal to. Okay. This becomes 2A square plus of what? 2A square into what? Cos theta equal to 2A square is the common factor into bracket 1 plus cos of theta equal to A square. This A square is what? Get cancels. So that 1 plus cos theta equal to 1 by 2. Or else cos theta equal to minus 1 by 2. This minus 1 by 2 is the cos of 120, that is theta equal to 120. Therefore, theta equal to what? 120 degree. Because we know that cos of 120 equal to cos of 120 equal to minus of theta. So that this is the right choice. Next, the length of the sonometer wire is AB is 110 centimeter. Of course, I have not solved in the regular class. Where should the two bridges be placed from A to divide the wire into three segments whose fundamental frequencies are what? 1:2 what? 3 here. This equation, this problem is based on the sonometer where F equal to 1 by 2L into square root of what? T divided by what? Yeah, this is based on this. Here only the relation between F and L is important here. F is inversely proportional to what? L here, that is. Okay. Understand. This is the wire. Now, this point I will call it the X. This point I will call it as a Y. The total distance is how much it is? It is 110 centimeter. Okay. This wire I will divide into three parts such that the frequencies F1 is to F2 is to F3 equal to, in the ratio 1:3 is to what? L. Here can I write like this? F is directly proportional to L or L is directly proportional to 1 by F. Can I write like this? So that here L1 is to L2 is to L3 equal to or directly proportional. 1 divided by F1, 1 divided by F2, 1 divided by what? F3, that I will write. But fundamental frequencies are in the ratio of how much? 1:2:3 has given. So that L1 is to L2, L3 is 1 divided by 1, 1 divided by 2. It is 1 divided by what? 3. Take the LCM and all that. So that L1 is to L2, L2, L3 equal to, it is 6:3:2, that is here, directly proportional, that is. This is 6 part, 3 part and this is what? 2 part. Then how to do such kind of ratio now? Total length is 110 centimeter. Now this 110 centimeter I will divide into 6 part plus 3 part plus 2 part. That means 6 plus 3, 9 plus 2, that is what? 11 part I will do it. It becomes what? 10 centimeter. 10 centimeter for one part. But for the 6 centimeter, it is 60 part. That means L1 equal to 60 centimeter. Remember that. For L2 is 3 part. 3 part means L2 equal to 30 centimeter. Then L3 equal to what? 1 part is 2 part. 2 part means it is 20 centimeter. I will divide the wire into what? One is 60 centimeter and another one is 30 centimeter and another one is what? 20 centimeter. Interesting problem. So that this is the right choice. 60, 30 and 20. Next problem. This problem is also okay. The fundamental frequency of a closed pipe is 220 Hertz. Closed pipe, he said that. Fundamental frequency of a closed pipe. Okay. This F equal to how much? 220 Hertz is that. Okay, fine. If 1/4 of the pipe is filled with water, okay. Now this pipe is what? Now it is filled with water. This is the pipe. This whole length is what? L it is. Now it is L by 4 and this will be 3/4 of what? L is there. 3/4 of is what? Air is filled. Here it is what is filled here? Water is filled here. Remember, I need air column, that is. It is an air column, that is. Okay. Now, for this, F equal to V divided by what? 4L. Why I am using fundamental frequency for which pipe here? Closed pipe. For the closed pipe, formula is F equal to what? V divided by what? 4L. That is. Okay. Therefore, V equal to 4L into what? F here. V equal to 4L into, it is 220 equal to how much it is? 880 into what? Yeah. Now, come to this. For this, first you calculate the fundamental frequency. You calculate for this pipe F dash equal to V divided by 4. Of course, it is a closed pipe. Length, don't write L. Don't write L. Yeah, here you have to write what you have to write here. 3/4 of L. You have to write it. 3/4 of L. You have to write it. I can do it in the shortcut method also. I can do it here. F dash equal to V divided by 4L into, can I write like this? 4/3. Here you see this F dash equal to, what is this V by 4L is nothing but what it is, 220 Hertz, 220 into what? 4 by what? 3. Even no need to do all these steps, also not required. Okay. But he is asking the what? First overtone. First overtone for which pipe? Closed pipe. 1, 3, 5, 9. This is the first overtone. First overtone is how many times it is more here? 3 times more than the what? Fundamental frequency. 3 times. So that first F double dash. It is what? Which one? First overtone frequency equal to 3 times of what? F dash. 3 times 3 into 220 into 4 by what? 3. This 3 get cancels. Equal to 880 Hertz. This is the formula. Yes, answer. No need to do this one. It is not required. It takes more time for you. That is. Here in such kind of problems, what is important is air column is important here. That is. In some books has given half of the pipe is filled with water. That means remaining half is what? Filled with what? Air and all that. But in some books, same problem is solved here with open pipe. Open pipe, where it is different. That formula will be different. To L that you have to use it. But students, though it is the pipe is, suppose if it is open pipe, okay, it is outside. Now I will insert it in the water, same pipe. Now at the time, this will become open pipe, will become a closed pipe, because at the end, it is the water is there now. So that it becomes what? Closed pipe it becomes. I hope that you understood or not. I don't know that is. This is a pipe when it is outside. The same pipe when it is filled with water, when it is what? This end, it will no longer, it becomes open pipe. This will become a closed pipe here. Next. 2 sound waves with wavelength 5 meter and 5.5 meter respectively, each propagate in a gas with the velocity 330 meter per second. We expect the following number of beats. Okay, beats equal to what? Difference in frequency. First, lambda 1 equal to what? 5 meter. Then lambda 2 equal to what? 5.5 meter. And velocity is same. Velocity V1 equal to how much? 330 meter per second. Here also V2 is also how much? 330 meter per second. Same gas, in a gas. Okay. Now, each propagate in the same gas medium. That is, each is used. Then F1 equal to V by what? Lambda. V1 by lambda 1 equal to 330 divided by what? 5. Similarly, F2 equal to V2 divided by lambda 2 equal to 330 divided by what? 5.5. Definitely F1 is what? More here. If we calculate this, F1 becomes what? 66 Hertz it becomes. Then this F2 becomes what? 60 hertz it becomes. If one can calculate 3300, I will calculate decimal, I will cancel it, so that 55 this is what? 5560. So that the beats equal to the number of beats equal to difference in frequency. It is F1 minus of F2 equal to 66 minus 60 equal to what? 6 hertz. So that this is the right answer. 14. Oh, interesting problem. Okay. A source of unknown frequency gives 4 beats when sounded with a source of unknown frequency 250 hertz. Okay, that's okay. One is unknown, that is source is that. I don't know what is that here. Unknown source. This frequency is here. And known is what? 250 hertz is that. Known. That is what? Known. It is how much? 250 hertz is there. When both are sounded together, how many beats are produced here? 4. Difference. That means 250 is there now. Possibility is either 250 plus of 4 equal to 254, or else 250 minus of 4 equal to 246 hertz. That means this unknown frequency, it may be 254 or 246. Okay, this is the first step. Next, the second harmonic, second means 2 times of F. Second harmonic means it is 2 times of what? F. Okay, second harmonic. Okay. The second harmonic of the source of unknown frequency. First I considered unknown frequency is what? F. Second harmonic means what it is? 2F. That I don't know that is. Okay. When it gives 5 beats per second when sounded with a source of what? 513. That is 513. That is. Okay. Now, this 256 it becomes 1 minute. 256 it becomes now. It becomes 2 times. 2 times. It means it is 508. This will be 246. This becomes what? 492. That is. It gives how many beats? 5 beats. It gives 5 beats. 5 beats. Okay. 5 beats means it is 513. One possibilities, and another one is that is okay. Here 513, and this will be 492. It is 513 source. 513 minus of what? 508. How much it is? 5. And take the difference of these two. You give it. It gives how much it is? 513 minus 492 equal to, that is 21. I think that is 21 beats it becomes. Problem is clear. I don't know that is. Second harmonic. The second harmonic, that means 2F. So that I multiply with this. 2 times 508. This 246 multiplied by 2. I don't know still whether this is right or this is right. Upper one is right or lower one is right. I don't know that is. When sounded together, it forms 5 beats per second. 5 beats. 508, 513. This will become 21. And we know that in the beats chapter, the maximum number of beats heard by the person is what? 10. So that this is not at all possible. Then this must be what? 508. Then off of it, it is what? 254. So that this is the what? Original frequency. That is what? 254. Okay. Now 254 is the what? The correct frequency. 254. Yes. This is the 250 plus 4. This is the original frequency of it. Next. A train is approaching the platform with a speed of 4 meters per second. Another train is leaving the platform with the same speed. The velocity of the sound is 320 meters per second. If both the trains whistling, then whistles of the frequency is how much? 280 hertz. The number of beats heard. Number of beats heard means you have to calculate F1 and F2 here. We know the standard equation. F dash equal to F into bracket V minus of V observer divided by V minus of what? V. This is the standard formula. I told you this. Okay. Here the person is standing on the platform. That is okay. Here one train is approaching. That is train 1 is approaching. That is train 1 is approaching. With what speed it is approaching? V observer, Vs equal to 4 meters per second. It is the source. Okay. The original frequency F equal to how much it is? 280 hertz. This is the frequency. Okay. These are the given data. When the train approaches here, now you have to calculate the apparent frequency, so that F dash equal to, you see, it is 280 into bracket. What is the speed of the sound has given? 320, that is 320 minus of 0 I am writing because listener is in what? Rest condition. Divided by 320 minus of what? 4 meters per second I am writing this one. Always when the train approaches, the apparent frequency increases. Apparent frequency increases means the denominator quantity should be less always. So that minus I have taken. So that F dash equal to 280 into what? 320 minus 316. You have to calculate F dash. Then next. Second case. Of course, person is standing here. Another train is there. This another train, it is leaving now. That is another train is departing. It is going away from this. This is train away from this. With the same speed it is going. Velocity of the source equal to what? 4 meters per second here. Now, here F double dash equal to 280. Of course, he is a rest condition here. 320 minus of 0 divided by, you see, the denominator quantity. Now when the train is going away means frequency decreases. Frequency decreases means denominator quantity should be what? More here. That's why you have to write 320 plus of what? 4 you have to write. So that F double dash equal to 280 into bracket 320 divided by what? 324. This is equation number 1. This is equation number 2. That is, which is greater? Denominator. This is F dash is greater than what? F double dash. Next I have to calculate the number of beats. I have to calculate. Number of beats equal to F dash minus of what? F double dash. Here you see 280 into what? 320. It is common here. That is 220. This is common. This also it is what? Common. Only what is left here? That is into bracket 1 divided by 316 minus 1 divided by 324. You calculate, then you will get the number of the beats equal to 7. You are getting beats equal to 7. Little bit calculation is there here. That is, no, that number of beats heard is what? 7 here. Next, 16th. Two cars moving in opposite directions approach each other with a speed of 22 meters per second and 16.5 meters per second respectively. The driver of the first car blows a horn. Okay. And what is the frequency? 400 Hz. then the frequency heard by the driver of the second car here. Okay, draw this line. This is the train car. Okay, approaching, that is, this is that one car, and this is what another car here. Another car. Both are moving in the opposite direction because he told that approaching each other. Okay. This speed is what 22 meter per second. This speed is what 16.5 meter per second. Alright. The driver of the first car, frequency f equal to how much? 400 hertz here. Here he blows the horn here, that is what? He blows the horn, that is like this. These signals are heard, sound signals are heard by the whom here? Second car driver, that is. Here you students, remember, this will be acts like a source. This will be acts like a what? Observer, that is. Because the observer is what? This one, that is. Now, we know standard equation. F dash equal to F into bracket V minus V0 divided by V minus of what? Vs. Here when both are approaching, apparent frequency is what? Increases. Apparent frequency increases means the numerator quantity should increase and denominator quantity should what? Decrease. I told you several times. This is the hint. Now here Vs equal to 22 and Vo equal to 16.5 meter per second here. Observer is, he is a listener or observer. This will be as like a source. Now F dash equal to, F is how much? 400. Here I am writing V plus of Vo divided by V minus of Vs I am writing. Because apparent frequency is what? Increases. That means numerator quantity should increase, denominator quantity should what? Decrease. So that F dash equal to 400 into bracket, what is the speed of sound? 340 has given. 340 plus observer means this one, 16.5 divided by 340 Vs means what it is? 22. Yes. Calculate all these things. It comes around 448 hertz. This is the right choice. Next, 17th. I solved this problem in the regular class also. A source of sound S is emitting the waves of frequency 100 hertz and observer O. Okay. This component of this along this direction we have to take it here. Vs equal to V into what? Cos of what? 60. But observer is in what condition here? Rest condition here. Rest condition. Now we have to use the equation, standard equation. Again I am writing F dash equal to F into bracket V minus of V naught divided by V minus of what? Vs. Of course, here observer is in what? Rest condition. So that F dash equal to F into bracket V divided by V minus sign because it's approaching, no? So that it is Vs into what? Cos of what? 60 you have to substitute. Okay, fine. This F dash equal to frequency is how much? 100 hertz. 100. Okay. Into bracket. Velocity is how much it is? 330 divided by 330 minus. Source is traveling at the speed of how much? 19.4 into 1 by 2 I am writing because we know that cos of 60 equal to 1 by 2. Then simplify. F dash equal to 100 into 330 divided by 330 minus 19.4. It is comes around 9.7. 9.7. But then this simplified, it is close to this quantity is 10, you can say that, equal to 100 into 330 divided by what? 300 and what? 20 it is. 330 by 320, it is roughly, it is more than 330. It is what? 1 point more than that it comes now. So that this will be more than 100. This is more than 100. More than 100. 103 also is there. 106 also is there here. Now, if I calculate, this comes around 103 hertz. 103 hertz. Next, 18th. The driver of a car traveling with speed 30 meters per second towards a hill sounds a horn of frequency 600 hertz. If the velocity of the sound is what? 330 meters per second. The frequency of the reflected sound, he is asking. Okay, draw this. This is the car. Okay. This car is traveling with a speed of how much? 30 meters per second. 30 meters per second. What is the frequency as given? Frequency equal to 600 hertz. Okay. And velocity of the sound has given. Velocity of the sound equal to 330 meters per second. Here is a hill is there. Hill that is. Now, the sound waves will be travels like this and then reflected back. This is the what? Reflected back. The frequency of the what? Reflected sound waves he is asking. That means f dash equal to f into bracket v minus of v naught divided by v minus of what? Vs is the standard equation. Here the source is moving, is assume that he is an observer here, that is observer. You are moving towards the observer. So that f dash becomes f into bracket v plus of what? V naught. Numerator quantity should increase. And then you are moving towards the reflected, that means it is a source, reflected source. So the denominator quantity also what? Decrease, that is what? V minus of what? Vs. So that both are 30 only, that is observer and this one, that is f dash equal to 330 into bracket v is how much? V is how much? 330. Okay, 1 minute, I made a mistake. F equal to 600 hertz. It is 600 hertz. So that f dash equal to 600 hertz into bracket, that is 330 minus of what? 30 divided by 330 plus of what? Sorry, this is plus and this is what? Minus of what? 30. This is f dash equal to 600 into 360 divided by what? 300. This 0, this 0, it cancels. 3 1 ja, 3 2 ja equal to, that is I made any mistake. Okay, here this 0 is not cancels. This 0 is not cancels. It comes around 720 hertz. Okay, f dash equal to 600 into 360 divided by 300. This 0 get cancels. 3 1 ja, 3 2 ja. So that it becomes 2 into 360 equal to 720 hertz. Is that 720? Yes. Next, 19th. Two tuning forks P and Q when set vibrating gives 4 beats per second. If prong P is filed, I told you whenever the tuning fork is filed, scrapped, something, frequency will be what? Increases. Now the beats are reduced to what? 2 per second. What is the frequency of P? Okay. Now I will give the two tuning forks. This is Q. This frequency is what? 250 hertz. Okay. And another tuning fork is that this is what P. I don't know what is the frequency of this. This is F. Unknown frequency. P is what? Unknown. It is. That is unknown. Now the number of beats heard in this case, number of beats heard, it is how much it is? 4 beats are heard in this case. So that the possible frequency of F is two possibilities. One is 250 plus a 4 equal to 254, and another one is 250 minus 50 equal to 246 hertz. Okay. Still I can't judge it. Which is right? 254 is right or 246 is right? Then second case, tuning fork after filing, that is after filing. Which tuning fork is filed here? Unknown. This is the what? P. This is what filed. Okay. This is remains same only. That is remains same. What is this value here? It is 250 hertz. Okay. Now, in this case, the number of beats equal to how much it is? 2 beats heard per second. Of course, this frequency is what? F dash. Now, F dash is two possibilities. 250 plus of 2 and another one is 250 minus of 2 equal to 252 hertz, and this is 248 hertz. I told you students, whenever the tuning fork is filed, its frequency is what? Increases. Its frequency is what? Increases. Suppose addition part, if I take this one and this one, not possible because it is decreases. So that this is not. What about this situation here? In this second one, you see, it is 246 hertz is there. Now it is increased 200 and what? 40. These two, you see, compare it. So that this is 250 minus a 4 means 246 is the what? Right answer. Next, 20th. Okay. An observer standing at station observes a frequency 219 hertz. When train is approaches. When train is approaching, one frequency. When train is going, frequency decreases certainly. It is 184 hertz. If the velocity of the sound is 340 meters per second, but I need to calculate two factors. One is velocity of the train and actual frequency or initial frequency. Okay, fine. Now, this is the train. Okay. Train is moving towards the observer or listener. Okay. When it is approaching now, what is the frequency? F dash equal to how much? 219 hertz. Okay. Velocity of the sound is given 340 meters per second. Now, standard equation, F dash equal to F into bracket V minus V0 divided by V minus of what? Vs. Of course, this fellow is in rest condition. That is rest condition. Observer is in what? Rest condition. So that F dash equal to, now I can write F, I don't know that is. The speed of the sound has given 340 minus of 0 divided by 340 minus, what is the speed? It is the speed of the train, velocity of the train, that you have to find it. Okay, it is what? Vs. Okay, fine. That means F dash equal to F into bracket, it is 340 divided by 340 minus of what? P. But I know f dash, I know that. How much is given? 219. So that 219 equal to f into bracket 340 divided by 340 minus Vs. This is equation number 1. Next, students. Now the observer is here only, that is. But now the train is going away from him, with the same speed. Now, same speed means how much? Okay, that is what? Vs. Now, apparent frequency in the second case, it is how much? It is 184 hertz. 184 hertz. Now, train is leaving away from him. So that now the second part I will write like this: f dash equal to f into bracket v divided by v minus of what? V. This is the formula. So that 184 equal to f, I don't know, and the speed of the sound is 340 divided by 340 minus of what? Vs. This is equation number 2. It is. Now you have to solve both equations. You have to solve it. Divide it. By dividing that, what you will get? Well, there are two unknowns and two equations. Two unknown and two equations. Divide equation 1 by 2. So that 219 divided by 184. This is 184. This is 219. By dividing this f is what? Get cancels. Equal to, it is 340 divided by 340 minus of Vs into this factor. 340 minus of Vs divided by what? It is 300 and am I making a mistake here? Anything? Okay. What mistake I made is, here it is plus sign. It is what? Plus sign. This will be plus sign because train is going away. That's so that this factor get cancels and simplify it yourself. Then you are getting Vs equal to 29.5 meter per second. Because the train is going away now. So that when the train is going away means this equation, it becomes minus, it becomes what? Plus here. Because denominator quantity should increase because apparent frequency decreases. Then substitute this Vs in any one of the equation and then calculate f equal to, it is 200 hertz you are putting. Yes, you do it yourself. Simplification. Next, the ratio of the speed of sound in the nitrogen gas to that in the helium. Okay, now recall it. Of course, I have not solved in the regular class. V equal to gamma into P divided by what? Rho here. Or else V equal to, I told you that, gamma divided by what? M, that is what? Molecular weight it is. Because density equal to mass divided by volume, so that this is into what? P into what? We can write. Okay. Density equal to mass by what? Here M is molecular weight you have to consider. Molecular weight. That means important, this one, that is important. Velocity is directly proportional to gamma divided by what? Yeah. Here two gases are there. One is nitrogen gas and another one is helium gas. Helium is what? Monoatomic. I told you that is. Helium is monoatomic. Because why I have not explained this question is because you have not studied which is monoatomic, which is diatomic. And nitrogen gas is what? Diatomic gas. Recall it. Decrease of gamma equal to, we know that formula, 1 plus 2 divided by what? F here. Very interesting problem. For the monoatomic, Gamma equal to 1 plus 2 by 3. I told you for monatomic degrees of freedom F equal to what? 3. It becomes what? 5 by what? 3. It is for which gas? Helium gas. For diatomic gas, gamma equal to 1 plus 2 divided by, for degrees of freedom for diatomic gas equal to what? 5. This is equal to what? 7 divided by what? 5. We know the gamma of helium and gamma of what? Nitrogen is. Then V is directly proportional to gamma of is asking the ratio of nitrogen to that. Nitrogen, 1 minute. I will write the equation. Velocity of gas in the nitrogen divided by velocity of the gas in helium equal to, can I write like this? Gamma of, directly proportional to, it is nitrogen divided by gamma of what? Helium, multiply by molecular weight and velocity, how they are proportional? Inversely proportional. So that this is the molecular weight of helium divided by molecular weight of what? Nitrogen. You know the molecular weight of nitrogen is what? 28. And molecular weight of helium is what? 4. We know this. This is equal to, yes, what? Nitrogen, it is 7 divided by what? 5. This will be, it is 5 divided by what? 3. Correct? N2. Molecular weight of helium is what? 4. This molecular weight is what? 28. So that 4 1 ja, this is 4 this 7 get cancelled, equal to, it is 3 divided by 5 into what? 5. Simplify this 5, this 5. This is equal to square root of 3. Square root of 5 is square root of 5. It becomes what? 5. So that square root of 3 by 5 is the right choice. Important problem students. This is, I have not solved in the regular class. Okay, next. 22nd. It is similar, that is. The monoatomic ideal gas 1 and 2 of molecular masses M1 and M2. That means V is inversely proportional to what? M here. Both are monoatomic, so that no need of gamma here. Simply it becomes V1 divided by V2 equal to square root of M2 divided by what? M1. So that this is the right choice. Because gamma is same here. Gamma is same. Gamma is what? Same. Next. 23. A string of 7 meter length, mass has given. The tension in the string is 60.5 Newton. Then the speed of the wave equal to, recall it, V equal to square root of T divided by what? M. What is M here? M is called mass per unit length. Mass per unit length has given. That is M equal to total mass divided by what? Length. What is the total mass here? It is 0.035 divided by length is what? 7. This is equal to, I think, 0.05 meter. Sorry, kg per meter. Kg per meter. Then substitute this. Velocity equal to square root of tension is 60.5 divided by what? 0.05. You substitute. That if you substitute all these things, now alter it, I think 2 decimals, 6050 divided by what? 5. This comes around 110 meter per second. It comes. 60.5 means 605. Okay, 1 decimal point. I think you can understand. This is 60 5 into 10 to the power minus 1. This is 5 into 10 to the power minus 5 1 ja, that is equal to 5 1 ja 1, 5 2 1 into what? 10 into 10 equal to 1 to 1 0, 1 to 1 0. Okay, that comes 111 square root is what? 121 here, like that it is. Okay, 110 meter per second it comes. Okay, roughly just do it. 121 means 11 square. Next, 24th. Not this. A unknown frequency x produces 8 beats per second. Okay, unknown x produces 8 beats per second with a frequency of what? 250 hertz and 12 beats with 270 hertz here. Okay. There are two known sources are there. One is unknown source. This is what x. And this is what frequency, it is how much? 250 hertz. The number of beats equal to how much it is? 8 of case 1. That means the unknown frequency x, it may be two possibilities: 250 plus of 8, 250 minus of 8 equal to 258, and this is 242 hertz. Am I right? Next, same unknown frequency with another known source here. Another known source. Okay. This known source value is what? 270 hertz. This is unknown. Unknown is what? X only. How many beats are heard equal to the number of beats equal to what? 12 here. Okay. Now, this x, now it becomes 270 plus of what? 12. 270 minus of 12 equal to, it is 282 hertz, and another one is 258 hertz. 258 hertz. Unknown means it should have common same frequency, no? This and this. If this is f, this also what? F only. Then it is possible, I think, only for this, no? Okay, this. Is it not 258? Is it not 258? You see. So that 258 hertz is this one. Students, here one mistake is here in the data. You should not give 12 beats per second, because maximum number of beats heard by the person is what? 10. That is, data is wrong. Of course, according to this problem, that is what? 258 hertz. Next, 25. If the speed of the wave is shown in the figure 330 meter per second in the given medium, then the equation of the wave propagate in the positive x direction will be, okay, all are in what? SI units. Understand? First, you have to write the standard equation. What you have to write here? Okay. Here, look into this. From here to here it is one way. Yes. Then from here to here it is second way. Yes. Then again from I made mistake here. Okay. From here to here it is one way. Okay, next is from here to here, it is what? Two-way. Okay. And then from here to here, it is what? Another, that is what? 3 lambda. 3 lambda. Okay, student, 3 lambda equal to 0.25 meter. Okay. Amplitude equal to here, and the mistake is there in the figure here, that is amplitude equal to 0.05 meter. It will not match, because in the actual the problem is he has given only up to this, he has given, but while drawing the diagram in the question paper we made a mistake here. It is 2.5 wavelength, 2 by lambda by 2 equal to, it is 0.25 meter. So that this to get cancels, lambda equal to 0.25 meter, because none of the answers will not match. In the diagram itself it is wrong here. Actually I am supposed to draw this part, you have to delete it, so that it becomes 1 lambda, this is 2 lambda, this is what? 2.5 lambda, that is. Sorry for this. Of course I have given the choice for you. That's lambda as given, it is lambda equal to. Now amplitude equal to what? 0.05. Okay. And total length is how much? It is 0.25. So that this is lambda equal to 1 minute. 1 minute here. Actually, I saw it in the direct in the regular class also. X equal to 2 into lambda by 2. 2 into lambda by 2 or 5 lambda by 2? Yes, 5. Half lambda, 2. Second lambda, third lambda by 2, fourth lambda by 2, 5 lambda by 2. So that 0.25 equal to 5 times of what? Lambda by what? 2. So that this becomes 0.25 into 2. It is 0.5 equal to 5 into lambda. Therefore, lambda equal to 0.1 meter something it comes. 0.1 meter. Then accordingly, you can calculate 330. The speed is what? 330 meter per second. Of course, all amplitudes are same here. That is, so that y equal to 0. You use the equation a into sine of 2 pi by lambda into bracket vt minus of what? X. This is the standard equation. So that y equal to 0.05 into sine of 2 pi divided by lambda is how much? 0.1 into bracket. Velocity is how much is given? 330 into t minus of what? X. 0.1 nothing but 1 by 10. If you calculate, y equal to 0.05 into sine of 2 pi, of course it is 3300 into t minus 10x. This is the right answer. 3 minus 10. This is the right answer. Students, problem wrong with question, that is figure actually. Only it is what? 5 lambda by 2. This is 1 lambda by 2, second lambda by 2, 3 lambda by 2, fourth lambda by 2. This is 5 lambda. It should not given, that is. Wrong with the question. 26th. If the frequency of the wave is increased by what? 25%, then the change in wavelength is given, that is okay. But medium is same, indirectly is given, velocity is constant. V equal to F into lambda equal to constant. This is the what? Constant. That means F1 lambda 1 equal to F2 into what? Lambda 2 here. Here the frequency, if the wave frequency is increased by 25%, okay, 25%, there can I write lambda 2 equal to f1 lambda 1 divided by what? f2, that is, okay. This is equal to lambda 1. Can I write 25% nothing but 1.25? It is f1 nothing but 1 have to take it. I told you several times. 20% means 1.2. 25% means 1.25. That means lambda 2 becomes lambda 1 divided by 1.25. Wavelength is what? Decreases, of course. Okay. Now, decrease is possible. Decrease means this is not only. Choice is between 20% and 25%. What is the change in, he has given here? The change nothing but what? The percentage of change equal to lambda 1 minus lambda 2 divided by lambda 1 into 100. You might ask question, why you have taken lambda 1 is minus lambda? Because lambda 1 is more. This is equal to lambda 1 minus lambda 1 divided by 1.25 divided by lambda 1 into what? 100. Into 100. Lambda 1 get cancels. This is equal to 1 change divided by 1 divided by lambda 2. Then you calculate all these things, it becomes divided by it comes around 20%. It comes because it becomes 0.25 divided by 1.25 into what? 100. This comes out, translates into 20%. 20% decrease it is. 27. Because in the previous problem you say, I think here, when the f v equal to what? F into lambda. Here, when the f is, what happens now? Increase now. When the f increases, lambda should decrease here. Lambda should decrease. Okay. In the given progressive way, y equal to this, where x and y, the maximum velocity. What is the equation? V maxima equal to, what is that formula? A into what? Omega. A is nothing but 0.5 equal to 0.5. Omega is nothing but this 100 into what? Pi. This is equal to 0.5, this one 50 omega t. Okay. No. 10, no, it is not, okay, 10 pi. This means 5 into pi. It is what? 5 pi is the right choice. This one. Next, 28. For this equation, that is y equal to 1 divided by root a into what? Sine of omega t plus 1 plus or minus 1 divided by root p into what? Cos of what? Omega t. I told you the regular class, that is r equal to resultant amplitude equal to p into what? Sine of theta plus of what? Q into what? Cos of theta. Some general formula I told you, that is the resultant amplitude r equal to square root of p square plus of what? Q square. I told you this. This is r equal to square root of p is nothing but this quantity 1 by root a. Q is nothing but this, so that it becomes 1 by a plus 1 by b equal to, it is a plus b divided by what? ab. This is the square root. Which one? This one is the right choice. 29. Okay. Two equations as given. Here y1 equal to a into sine of 2000 pi into t. It is nothing but omega 1. Omega 1 equal to 2 pi f1 equal to, can I write 2000 into what? Pi. So that this pi get cancels. 2 1 ja, this is 1000. So that f1 equal to what? 1000 hertz. Okay. For the second equation, y2 equal to a into sine of 2008 into what? Pi into what t. This is nothing but omega here. Omega 2 equal to 2 pi into what? f2 equal to 2008 into pi. This pi get cancelled. 2 1 ja, this is 1004. So that f2 equal to 1004 hertz. This is 1000. This is 1004. Difference gives what? Beats. Beats equal to 1004 minus 1000 equal to what? 4. 4 is the right answer. Last question. 30. Okay, similar kind of problem already solved. 10 tuning forks are arranged in the order of increasing order. How many tuning forks? That is. And what is the beats here? Successive tuning fork? 4. One is F. Next is F plus 4. F plus of 8. Plus so on. For the 10th tuning fork, you have to write minus 1. You have to write it. F minus of 9 into what? 4. This is the story of it. Sorry, F plus you have to write it, because 10th tuning fork, no, 10th means 10, 1 less you have to write it. This is called as a first tuning fork. It is a first or lowest frequency. This is the last tuning fork, and it has got highest frequency. He is asking both highest frequency and lowest frequency. Here, twice highest frequency is twice that of the what? Lowest. The highest, this is F plus of what? 36 equal to 2F. I am writing. Yes or no? Or sometimes it is called as an octave. That is, you use the word octave. That is, so that 2F minus of F equal to what? 36 hertz. Students, this would be 36 hertz, and this is 2 times means 10th tuning fork. It means double means it is what? 72 hertz. 36 and 7. Highest and lowest is asking, so that this is the right choice. Okay, my students, I will end my session at this point.